Hi, I'm Kit Carney,
And I'm Sophie Earhart.
and this is our physics Rube Goldberg analysis video.
Our goal for this project was to design a machine that would cut a cookie in half.
Our hypothesis was that a series of steps will cause a pin to pop a balloon, which would cause something to fall and cut the cookie.
For our method, we worked backwards from the cookie cutting and decided to utilize mostly gravity as the force that would cut the cookie.
Here is our final product.
Here's a step-by-step breakdown of our project. The Newton's cradle utilizes Newton's first law, which states that an object at rest tends to stay at rest and an object in motion tends to stay in motion unless compelled to change by a net external force, in other words, inertia. We did work on the Newton's cradle by giving the balls at the end potential energy, the energy associated with an object due to its position in a gravitational field. And then when we released the balls, that energy was converted into kinetic energy, which is the energy associated with an object due to its state of motion. The ball at the end of the cradle continued to swing because of inertia and eventually hit the golf ball, which was our next step. Newton's third law was also involved, and Newton's third law states that when one object exerts a force on a second object, the second object exerts a force back on that object that is equal in magnitude and opposite in direction. So basically, for every action force, there's an equal and opposite reaction force. One force pair is each individual ball in the Newton's cradle with its neighbor, and the other is the last ball with the golf ball. All the collisions in this step were elastic collisions, which is a collision in which objects collide and bounce apart, so collision with itself and the collision with the golf ball. And the law of conservation of linear momentum, which states that the total vector of a system will remain constant if the net external force is zero, is true because the potential energy we gave the Newton's cradle initially was then transferred through the Newton's cradle to the golf ball.
At the top of the ramp, the golf ball is not moving due to inertia. At the top of the ramp, the golf ball also has gravitational potential energy due to its height. When the Newton's cradle hits the golf ball, this exerts work onto the ball, which then transforms the gravitational potential energy into kinetic energy. Newton's second law is present when the balls from the Newton's cradle hit the golf ball. Newton's second law is that when a net external force is applied to an object, it causes the object to accelerate, change its velocity in the direction of the force. The acceleration is directly proportional to the net force and is inversely proportional to the mass of the object. So in this case, the acceleration caused the golf ball to go from 0 meters per second to actually begin moving. The ramp directed the motion of the ball to the dominoes. There was kinetic frictional force, which is the frictional force acting between objects that are moving relative to each other during this step. However, the coefficient of friction between the ball and the board was not significant enough to stop the golf ball from going down the ramp.
Newton's second law is also present in this step because when the golf ball applies a force to the domino, it causes the domino to move. And the work that the golf ball does is what gives the domino motion or kinetic energy. As the domino falls, it has torque, which is the quantity that you apply to an object to change the object's rotational motion. And the pivot in this case is the bottom of the domino. And because the top of the domino has greater displacement than the bottom, the motion of the domino is rotational.
When we set up the mousetrap, the copper bar that is attached to the string is fixed at the far end of the mousetrap and is free to slip out from under the hook that holds it in place. As the domino falls, the kinetic energy of the domino is transferred to the hook and causes the hook to change its position, which then releases the spring. The elastic potential energy stored in the spring is transferred into kinetic energy as the spring moves, flinging the bar and the string forward.
In our setup, the pin was attached to the string on the mousetrap and held the Mentos above the Diet Coke in a tube. Because of Newton's first law, the pin stayed at rest until the mousetrap, which was the net external force, did work and caused the pin to move. Because of Newton's second law, when this net external force was applied, it caused the object to accelerate and release from the tube above the Diet Coke. As it is pulled out, the pin has kinetic energy.
Before the pin pulls, due to Newton's first law, the Mentos stay at rest in the tube above the Diet Coke. When the pin is released from the tube, however, gravity is free to do work on the Mentos and causes them to move. As the Mentos move down the tube toward the Diet Coke, they have kinetic energy.
When the Mentos fall into the Diet Coke, a chemical reaction occurs. The numerous small pores on the candy's surface catalyze the release of carbon dioxide gas from the soda, resulting in the rapid expulsion of copious amounts of foam.
As the Diet Coke foam hits the poster board located directly above the 2-liter, the foam does work on the board, causing the board to go from a state of rest to a state of motion. This inertia of the board can be explained by Newton's first law. As the foam hits the poster, Newton's third law is present. Torque is present as the external force of the foam acts on the poster and makes the poster rotate. A water bottle is attached to the bottom of the poster, creating a seesaw-like formation, and acts as the pivot. As the poster is rotated, it has kinetic energy.
As the board tilts, the bocce ball inside the tube attached to the board begins to roll. So it goes from a state of rest to a state of motion. It has projectile motion because it is in free fall motion and is also projected, so it is a combination of vertical and horizontal motions. As it falls, the ball has kinetic energy.
As explained by Newton's second law, as the ball falls into the box, it does work and causes the box to move downward, giving the box kinetic energy. The ball hitting the box is an inelastic collision, or a collision in which the objects collide and stick together. They travel together at the same final velocity. The elasticity of the rubber bands attached to the top of the box allowed the box to fall a small amount. The rubber bands were inelastic enough that they did not extend to the floor, but elastic enough that the rubber bands didn't break. In other words, the spring constant, or the force needed to stretch an object an entire meter, was good.
The string is attached to the box, and as the box falls, it does work on the string, an application of Newton's second law, because the box is the net external force that pulls downward on the string. The string then has kinetic energy.
The string does work on the wooden rod. Newton's third law is present between the wooden rod and the string. Because the string causes the rod to tilt, which results in rotational motion of the rod, torque is present. The pivot is the loop in which the rod sits. As the string causes the rod to rotate, the rod has kinetic energy.
Because of Newton's second law, when the rod does work and applies an external force to the pin, it causes the pin to accelerate in the direction of the force. Once the pin moves, it has kinetic energy.
Newton's third law is present when the pin does work by exerting a force on the balloon. As the pin pushes into the balloon pushes back until the balloon pops. The balloon is inelastic. It doesn't return to its original shape easily. The pin is able to easily pop the balloon because of its pressure, or small surface area. The higher pressure on inside of the balloon makes the air want to rush out of the balloon. The small puncture that the pin creates allows for the air to escape quickly. As the air escapes, it has kinetic energy.
Once the balloon, which is holding up the metal rod, pops, the rod is in free fall motion and is free to move and is only affected by gravity. Therefore, its acceleration due to gravity is a constant negative 9.8 meters per second squared. Newton's law of universal gravitation states that every two objects of mass in the universe will attract each other with the force of gravitation. Therefore, Earth attracts the metal rod. As the metal rod falls, it has kinetic energy.
When the rod falls upon the cookie, which is located directly below it, it does work on the cookie. The small surface area of the bottom of the paint scraper applies a great deal of pressure. or the ratio of force applied to an object divided by the area over which the force is applied to the cookie, which causes the cookie to break in half. There are many properties of physics that are applicable to every step within our project.
Normal force, the force that acts in a direction perpendicular to the ground, was present in each step, and acceleration, the rate at which velocity, so a change in speed or direction, changes over time, was also always present. While testing, the main problem that we had was that the blade that cut the cookie was not 10 centimeters above the cookie, and so for the final run through at school, we put our whole contraption up on the curb, but that made it very hard to line up where the rod was going to fall so that the cookie would cut exactly in half. And if we were to do the project again, we would probably want to mark exactly where on the ground the rod was going to fall so that the cookie would cut in half every single time. Another problem that we had was that the pin didn't always pop the balloon because it was hard to focus the pin into the balloon every time. And if we were to design the project again, we would find a way to direct the pin directly into the balloon so that there wouldn't be a chance that it would go beside the balloon or under the balloon.
One thing that worked really well in our project was the fact that gravity was consistent and it was a really reliable source of energy so that we didn't have to worry about wind affecting a large portion of our project. And overall, our project went pretty well because we didn't have to interfere whatsoever in any of our steps and it went all the way through. However, we did not get the full points because our cookie cutter was not exactly where it needed to be, so it did not cut the cookie perfectly in half.
This has been Sophie Earhart
And Kit Carney.
Hope you enjoyed our video.